me just record. So next week when we do the summative investigation, I think I have like 6 or 7 dot patterns I'm going to give you. To get a level 8, you only need 4. Like I'm giving you extra patterns in case, like sometimes you might look at it and be like, I can't figure this one out, but you can figure out others. And I get that, right? Like sometimes you just can see it and you can't. So we're giving you extra and then you don't have to do all of them. Okay, I can't remember the total number we're giving you. But otherwise, it's going to be basically the same thing that I've given you today. So this one shouldn't have been like shocking. So like on the first one, there's literally 2 dots here. There's 4 dots here. There's 6 dots here. What do you notice? They're the same, right? You should have noticed as well, like my pattern just grows taller. Those are terrible dots. I apologize. So our equation here is just going to be D equals F. Could you have written F equals D? Totally. Those are the same thing. Okay. It's really important that you're realizing on this. It's going to be within one column. So I don't want you referencing like the column before or the term before or the one before. That's something that we won't actually come to until like grade 12. So it's always going to be like a standalone. Yeah. Totally. Like that. Or like actually times 1. Totally fine. Lots of these you can write in slightly different ways. You totally can. Matt, can you close your computer so I know you're listening, please? The word description for how the dot pattern changes on here, it's really just describing the dots. I'm not going to write it out because I think you can hear me saying this, but on this one, it might be something like for every 2 figure numbers, an additional row of dots appeared on the top, right? Something pretty generic. You're referencing the dots. Where are the dots going? On this example in particular, the pattern's fairly straightforward, so that one's not that helpful. On some of the patterns, though, it's really helpful to be able to look at the diagram picture to help you get there. Verify your equation. This one, you literally would be like, oh, look, 2 is equal to 2. I'm right. 4 is equal to 4. I'm right. That's it. This is a simple pattern. So like there's only a max score I could give you of a 4. But if you did all of this, you would have done it perfectly for this one. Okay, let's go to the next one. This one was slightly harder. So figure number 1 has 3 dots, and then I have 5 dots, and then I have 7 dots, and then 9, and then 11. Do you guys agree? Each time it increased by 2. When you're coming up with this equation, there's a few ways you can do it, and I'm going to talk about some strategies here. So some of you might be really pictorial learners and look at the picture and be like, oh, I noticed that this 1 like floater dot on the side is constant. It always has this +1 kind of dot there. Oh, that's a hint that my equation is probably going to have a +1. Right? Like my words there as I just described it kind of help me. Then I'm like, oh, this one has 1 row of 2. Then I have 2 rows of 2. Then I have 3 rows of 2. I wonder if that's significant. Totally. And so when you're going through it, it might help you to try and describe the picture there to help you see that pattern. I personally am not a pictorial learner, so I personally just start playing. So I'm like, well, 1 + 2 = 3. 2 + 2 does not equal 5. That doesn't work. 1 × 3 = 3. 2 × 3 doesn't equal 5. Like I just start playing with the numbers to see if I can make it work. Because I knew there's this +1, for the first one, for that to work, I'm going to have to go 1 × 2 + 1. Oh, that equals 3. Oh, that works for everyone. And so that's where our equation comes in. So you're going to get 2f + 1 is equal to d. Does that make sense how you can get there? It's a lot of just playing with the numbers and recognizing the pattern. On this one, it's always 2 dots. That's why there's a 2. And then the number of rows of dots is my figure number. That's kind of how it relates. On this one, so I've described it verbally for you. On this one, when you're filling it in, so for example, the first one is 1 and 3, I would replace my d with the number of 3, and then I'm going to have 2 × 1 + 1. So then I would get 2 + 1, 3 = 3. Yay, I know I did it right. I could have done 3 and 7. So 7 is going to be equal to 2 × 3 + 1. 6 + 1 = 7. I know I did it right. Go ahead, Wyatt.
Where's the E?
That's an F. That's a handwritten F.
Wow.
Yeah, makes sense.
You got me right in the third grade.
I always just handwrite my F's. It's just what I do. I'm weird. And that's it. That's all you're gonna need to do. So next week on our rubrics, it says you have to be able to find simple patterns and then complex patterns. So we're gonna give you easier dots like these ones, and then we're gonna give you harder dots. Like the equation could be, maybe there's a fraction involved, so maybe it would be like 2f over 3 plus 1. That would be complex. We could do things with squares, so it could be f squared minus 5. Right? So those are going to be harder ones to see. The visual of the dots gets more helpful when they're more complicated as well. Okay? Any questions about that? Does that make sense? Yeah? Go ahead, Garrett. Yeah, go ahead. Okay, we're going to do lesson 5 now. So if you could take out your workbooks and turn to page 299. 299. Okay, so today we're going to talk about multiplying a binomial and a trinomial, or multiplying 3 binomials. So this is kind of like where it gets a little bit more difficult and where like context, I say that very loosely, comes into play. There's a few ways you can do this, and I'm going to go through a couple of the different ways. So their first example says a rectangle has a length of 5x plus 2 and a width of x squared plus 2x plus 1. So on this one, let's just fill it in. So length, I'm going to just rewrite. So they want us to solve this one 2 different ways. I'm going to use the area diagram. I'm not going to go through the distributive property method because I'll just do that later on, okay, just to save it. So I like the area diagram, especially on questions like this, because these ones can get quite messy. So our area, oops. So I'm going to draw out my little table. So we're not doing, you could do tiles here. It would be really unfortunate and messy to do tiles, but you could, but this is that like shortcut way. So I'm going to put my length here, 5x, my plus 2 here, so that term went up here, my x squared here, my 2x here, and my plus 1 here. So the area method's really helpful on questions like this because you can end up getting a lot of terms and it's easy to make mistakes, it's easy to mess up. So this kind of like just gives you a little bit more organization. So if you're someone who isn't super neat and gets muddled with things, use this method. I will, like next week, your review classes, I'm going to give you a review booklet that's leveled questions so you guys have an idea of difficulty. I also will give you a ton of space. Your workbook does not give you a lot of space. So for questions, I'll give you enough space that you could do it using this way. 5x times x squared gives me 5x cubed. 5x times 2x gives me 10x squared. 5x times 1 gives me 5x's. Okay, then I have 2 times x squared, so I get 2x squared. 2 times 2x gives me 4x's. 2 times 1 is 2. So from here, you would combine your like terms to get your final answer. Didn't give myself a ton of space. But when we do it, I'm going to get 5x cubed plus these 2 can combine to give me 12x squared. These 2 can combine to give me 9x's plus 2. And that would be our final answer. I'm going to show you the distributive property method on class example 2A, just so we have different numbers to play with is all. Can I slide down? So they're saying with distributive property, it's a method that I personally don't love because I feel like it's a lot of extra writing, but I will go through it because just because I don't love it doesn't mean you won't. So at the end of the day, I have to multiply every term in my trinomial by the x squared, and then every term by the minus 4. So they literally take this step of writing it out that we're going to do that. So then you would be 2x cubed plus x minus 5. So I'm rewriting that trinomial, and then I'm going to have minus 4 times my trinomial. We are going to go over the b example, so try and fit it in if you can. So from here, I'm simply multiplying in that x squared. Do you guys need a second? Yeah, sorry. Tell me to slow down when needed. I teach your class second, so I've already gone through all of this yesterday, so it's a little bit harder to make sure I'm taking the right pace. So when I multiply that x squared in, I'm going to do each term. So I'm going to get 2x to the power of 4. You add your exponents. X to the power of 3 minus 5x squared. Negative 4, I'm going to get minus 8x cubed minus 4x. And then negative times negative, be careful, it gives me a positive 20. Then, as always, we have to combine our like terms. I only have one term that has a degree of 4, so that guy goes first. I have x cubed and negative 8x cubed, so that gives me negative 7x cubes. Remember, there's like a 1 here. I only have one x squared term. I have one regular x term plus 20. Did I make a mistake?
Yeah, it's not 4x. It's not 2x to the power of 4, 2x to the power of 5. Because it's the original equation that has 2x cubed.
Oh, it's a cube and I wrote a square. Thank you. This should be a 3. I rewrote it wrong. And then this is a 5, and this is a 5. Thank you, Matt. Do you guys see what I did there? I'll highlight. Thank you. So there's that method to do it that way. That mistake I just made is a very common mistake, rewriting it wrong. Truthfully, if you made that mistake and you rewrote it, I don't really care. I get that that happens. I'm going to, like, on your test, because if you could show me you're just rewriting it wrong but still did, like, the math pieces correctly. Totally, that's for sure, too. But, like, you still added your exponents correctly, you just wrote it down wrong. I get that. We all make those kind of mistakes. Okay, this is a method I prefer that I'm going to show you on B. So on B, slightly different, they wrote the binomial second. I personally prefer just drawing arrows and not rewriting it. I personally am less likely to make mistakes. I'm not a super detail-oriented person, and so that helps me overcome that. So for example, in this first one, I'm going to deal with, I like doing the smaller one first. So I'm going to do y times 2y. Sorry, y times 2y squared. So that's going to give me 2y to the power of 3. Then y times my middle term gives me negative 3y squared. And then y times my 7. I think it's easier just to draw arrows to make sure I don't make a mistake and just do each piece then. The arrows also help ensure that you've done each term. Versus on the first one, I would have had to rewrite the y, rewrite the trinomial, rewrite the 6, rewrite the trinomial. Minus 6 here, I'm going to multiply that in. So then I get negative 12y squared. Negative 6 times my middle term gives me a positive 18y. And then my 6 times the very last one gives me a positive 42. It is kind of messy drawing the arrows, but it's kind of just what works for me. I really cannot stress that just because it works for me does not mean it's a better method. Don't feel like you have to do it the same way as the teacher. So now I'm going to combine my like terms. I only have one cube term, so I have my 2y to the power of 3, negative 3y squared, and negative 12y squared, so I get negative 15y squared. Negative 7y, positive 18 gives me a positive 11y, and then plus 42.
For a question like this, we're still allowed to use the diagram method?
Totally. Totally. You always can use the diagram method. It will work for every single one you come across. Okay, this next question is an awesome level 5-6 question. Looks scary, right? There's a lot going on. There's a lot of steps here. There's a lot of pieces. There's a lot of room for little mistakes. Unfortunately, that's kind of the case. I'm going to show you how I would go through this. Again, there's a few ways you can go through it. My first step, I'm going to multiply this outside 4 in so I don't forget about it. So you only multiply it into one piece. I'm also going to leave a bit of space so I can draw my arrows. 4 times a gives me 4a. 4 times 4 gives me minus 16. Okay, so that's us dealing with that first piece. I can't do anything right now with this trinomial, so I'm just going to rewrite it. Because eventually I have to multiply those two pieces together, but I want it rewritten so that way I don't make a mistake. Then this subtraction sign, I'm also going to rewrite that. That is really important that you don't forget about that piece.
Would that be worth adding right now?
Personal preference. Totally personal preference. I personally would rather do this multiplication right now and then put the negative in. One is not better than the other though. So now I'm going to do that trinomial. I'm going to put a big set of brackets so I don't forget to multiply in that negative, because remember, it's like there's a negative 1 right here. So if I want to put that 1, you go right ahead and put that 1. If you don't need to, don't worry about it. 4a times 4a gives me 16a squared. So we're doing FOIL. So that's first outer 4a times 3 gives me a plus 12a. Inner terms minus 12a. And then last terms minus 9. I have a plus 12 and a minus 12. Those two are going to cancel out. So now on this next piece, on this first part, we have to do that multiplication. 4a times a squared gives me 4a to the power of 3. 4a times 3 gives me minus 12a squared. 4a times minus 6 gives me minus 24a. Now I have to deal with that 16. 16 is a big number. Most of the ones I give you, I won't give you like 16s to multiply. You should be able to handle 16, but I don't want to like cause you to make a mistake just because you multiply funny. But minus 16a squared, I'm going to get a negative times a negative gives me a positive 48a. And then that's positive 96. That's a lot.
Wait, is the 16a squared?
Squared. There's not an a on the 16. Or can you not read my printing? And that was a positive for you. So now I'm trying to color code the best I can. Now I'm going to multiply in this negative into the second piece. So it's going to become minus 16a squared. Negative times negative makes this plus 9. I didn't write the extra line of showing that that positive 12 and minus 12 canceled out. You can just draw it, like if they cancel out nice like that, you can just scratch them out or recognize it in your head and continue on.
So you don't need to necessarily show that?
No. A lot of this stuff, as you guys can clearly see, a lot of these questions are hard. There's no way you can do all of this in your head. So for showing your work in this unit, show as much work as you need. I'm not going to get mad at you for not showing your work, because if you can do this whole question without showing your work, I'm going to believe you. You're doing it in front of me, you're not cheating, right? Like, I'm not going to have your test written at home. I don't think anyone could do this in their head. There's too much to it. Okay, from here, we have to combine like terms. I have one term that's a cubed, correct? So I'm going to stay with 4a cubed. Whoa. I have a couple a squares. So I have, just for my sake, when I do the math, I have negative 16 a squared and a negative 16. So that gives me a negative 32. Negative 12 gives me a negative 44 a squared. Negative 24a, and then positive 24a, sorry, positive 48 gives me a positive 24. 96 and 9 gives me 105. That is a big question. There's a lot of pieces, a lot of room for error, a lot of places to make a little mistake. How was that one for you guys? I would say a lot of this unit, like conceptually, that's not that hard to understand. It's just hard not to make a mistake. It's hard to like start it sometimes too, because you look at it and you're like, whoa, there's a lot there. Can I go into the next page? Good. Okay, we're gonna do two more and then you don't have to listen to me anymore. Okay, product of three binomials. So we have a box. What is the volume of the box? How do I calculate volume? Come on, guys. Good. Length times width times height. So the first question here is just says write an expression. When it says anything like that, we're going to have x plus 1 times x plus 2 times x plus 5. And you're done. I will likely ask you a question on your unit test. Just be like, write the expression. Set this up.
That's basically just write the equation down.
Yeah, totally. Don't do anything more. Don't solve it. Don't multiply it out. Just give me this. Then part B, it says expand it. I want to show you an example of how you could use the area method to do this. And then the next question on class example 5, I'm going to go through like the long way. So if you were to do the area method here, you have to do it twice. So the first area method I'm going to do is just for these two. If you wanted, you could do one, oh, that's messy. You could do one area and one like regular, doesn't matter. What works for you is what I care about. So I'm going to have x plus 1, x plus 2. X times x gives us x squared. 1 times x gives me an x. X times 2 gives me 2 x's. 2 times 1 gives me 2. So that gives me a trinomial. I'm doing this quickly, I apologize. Combine my like terms, and I get this trinomial. That's like part 1. Regardless of the method you use, you're going to multiply 2 together, get a trinomial, and then multiply it by your third binomial, or your third like side. So now I'm going to use the side I didn't use, so x plus 5. And then my trinomial is going to go on my other side here. X times x squared gives me x cubed. X times 3x gives me 3x squared. X times 2 gives us 2x. 5 times x squared gives me 5x squared. 5 times 3x gives us 15x. 5 times 2 gives us 10. So now you actually have to like write it out nice and pretty. So our final answer on this guy for the volume of our box is going to be x cubed. The diagonal is going to be what your like terms are going to come on. So 5 plus 3 gives us 8x squared plus 17x plus 10. Okay, one more question. You're done listening to me. I'm only going to do 5A, so you can give yourself a little bit more space. What they're getting here, if you look at these two questions, both of them have an x minus 3. Both of them have a 2x minus 1, and they both have x plus 4. Exactly. You're going to get the same answer. At the end of the day, I'm multiplying 3 numbers together, the same 3 numbers. Different order, but the order I multiplied does not matter.
Does that mean we have to do both A and B?
No, I'm not doing B because I think we can talk about it and not make you rewrite it twice. But do you guys see what I'm saying? It's the same 3 things. You're going to get the same answer. Your process is going to look vastly different. You're going to have very different numbers as you're working through. Same final answer. Let's just do A. I'm going to go through the just using the number method on this one. So we're going to start just doing FOIL with the first 2. So when I start with that FOIL, I'm going to get x squared plus 4x minus 3x minus 12. That stays in brackets because I still have to multiply it by this last binomial. That's our first piece. 4x minus 3x leaves me just with an x. If you can go straight to this trinomial, go right ahead. So now I have to make sure I multiply each number by each number. So 2x times x squared gives me a 2x cubed. 2x times x gives me a 2x squared. And then I get minus 24x. Now minus 1. With minus 1, I'm just changing the sign on each of them. So I get a minus x squared minus x plus 12. From here, combine like terms. 2x cubed has no friends. Stays by itself. I've dealt with it. I'm going to underline it. 2x squared minus an x squared leaves me with 1x squared. Good. Minus 24 x's, taking away another x, so I'm at minus 25 x's, and then my 12 ones hangs out. That's a big question. Takes a lot of steps.
What level would something like that be?
5. And those are nice friendly numbers as well. Okay, we have only about 10 minutes left in class, so this won't be due for homework, but you can start working on, there's some practice questions here. It's getting at the same things, but we will have some class time next week to work on it. And then lesson 6 is a very similar kind of lesson, just with more negatives.